Welcome to our third lecture of our probability series, in which today we are going to cover one of the most important topics, you can say, that is conditional probability and Bayes theorem. We are also going to cover total probability theorem also in this lecture. So let's go to our tablet screen to discuss more about these topics. So before starting these topics, firstly, I want to show you magic of probability by telling you to solve a question. So pause this lecture and try to attempt the question that is, you can say, in front of you. I hope you have paused the lecture and at least try to solve this question. And if it is not solving by you, no problem. I will solve it. Okay. The topic is magic of probability for this question. Okay. Answer. So first, let's read this question together. Assume your college has 17,000 pupils and you know 100 of them. You walk in a room of 268 random people. What is the probability that you know at least one person? That's question error. That you know at least one person. Okay. So let's define what is probability. Probability is favorable events upon में sample space. Sample space. Sample SPACE. Sample space. Okay. So first, let's bifurcate this question into two parts. First, let's try to find the sample space. We are the question is asking that there is a pool of 17,000 people. There is a pool of 17,000 people and we have to choose 268 peoples randomly. 17,000 choose 268. We have discussed it in our previous lecture. So this is our total, this is our sample space. Now what is favorable events? It is very difficult to find the favorable events. But if we are trying to find the unfavorable events, it is very easy. Let me tell you how. We have to choose. Let's read this question once again and let's put more emphasis into this question. Assume your college has 17,000 people and you know 100 of them. Okay. You walk in a room of 268 random people. What is the probability that you know at least one person? Now, we are not going to find probability of E because it is very difficult to find the probability of E. Here, we are going to find the probability of E complement. And as we know, probability of E complement minus 1 is equal to probability of E. This is a very well-known probability, not sorry, well-known theorem, right? Let me raise it. Okay, so you have to choose E complement 17,000 minus 100 people because 100 people you know, and you don't want to choose those 100 people that you know because we are trying to find probability of E complement here. Choose 268 because you have to choose 268 random people. They all are equally likely. So yeah, right. So this is the probability of E complement. Now I'm not going to solve this question, not going to solve this calculation on the tablet screen. I'm going to solve this calculation by taking help of a programming language called as Python. So let's go to our, sorry for that. So let's go to our Python screen to discuss more about this. So now, as you can see, we are on our Python screen. For those of you who are not familiar with this, this is a Google Colab notebook. So what we are going to do, we are going to import a library called as math, right? Now, what was our numerator in our probability of E complement? It was math.com. This is a function for choose or combinations. Okay, so for using the function for solving the combinations, we use math.com in our Python, which is provided by our math library, which was 17,000 minus 100. Choose 268. Simple, right? What was our denominator? Mind you, denominator is our sample space here. There was some error problem. Sorry for that. It is math.com 17,000. See, sometimes the Google Colab give wrong suggestion because it doesn't know your thinking, what you are thinking while writing the code, right? Choose 268. So don't rush blindly on AI. So what was our probability? It was 1 minus. Make sure we have find probability of E complement. Probability of E is equal to 1 minus probability of E complement. Numerator by denominator. There is no, you can put brackets here, but there is no need to put brackets because there is a rule called BODMAS. I think you must be familiar with the rule of BODMAS, in which division operation is conducted first. Print the probability is top. Now let's see the output. Can you see the output? There is approximately 80% chance that you know at least one person. Isn't that magic of probability? I think so. So now let's go to our tablet screen to discuss the further more topics. So now let's start the new topic, that is conditional, Conditional conditional probability. So what is conditional probability? The definition of the conditional probability is the probability of an event happening given that another event has already happened. Okay, I'm not going to write the definition. I'm going to explain the definition, which is the important part, right? So this event, which is F, has already happened. Now, what is the probability of event E happening given that given that event F has already happened? Okay. So this topic is most of the students consider this topic little bit of difficult. So let's take an example explaining this topic. For example, you throw two dices. What is the probability that the sum of two dices is equal to 4? What is the probability that sum equal to 4? Okay. Is event upon sample space? So what is the sample space when you throw two dices? 36. Now sum is equal to 4. What are the events? Let's write the events. If one dice is 1 and the second dice is 3, the sum is 4. If the first dice is 2 and the second dice is also 2, sum is 4. If the first dice is 3 and the second dice is 1, the sum is also 4. So there are three favorable events. 3. Probability of sum equal to 4 equal to 1 by 12. Now let's twist this question a little bit. What is the probability that the sum is equal to 4 given that the first dice, let's say the first dice is 2? Okay. Probability that sum equal to 4 given that dice 1 equal to 2. So we know that dice 1 equal to 2. Then what is the probability that sum is equal to 4? Now what will happen that our sample space is going to shrunk here. Initially our sample space was contain 36 elements. Now our sample space will contain 6 elements because first dice is equal to 2. So which is 2 comma 1. This is sample space that I am writing. 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, and 2 comma 6. This is our sample space. Now what is our favorable event? 2 comma 2. What is the probability? 1 by 6. So can you see the difference in the probability? When one event has happened and we are asked to find another event given that first event has happened. This probability can also reduce. This depends on scenario by scenario. So let's take a question. Okay. So let's take a question. Okay. Before taking this question, sorry, I forgot to explain you important part. Probability of E given F that we have written here. E given F. there's a formula. Probability of E intersection F, or you can say E and F upon probability of F. This is our formula for conditional probability. Now let's solve the question on this conditional probability. Firstly, I recommend all of you to firstly pause this lecture and solve this question. And I am here to solve the question, but I recommend you to first pause the lecture and solve the question. I hope you have paused the lecture and at least tried to solve this question. Okay. So let's read this question. This is a very easy question, solely based on this thing. Okay. Now let's read the question. Let E be the people who loves cricket and F be the people who loves football. E is equal to loves cricket, F is equal to loves football. We are given both of its probability. Probability of E is equal to 0.4 and probability of F, we are given it as 0.7. Now, find the probability of people who loves cricket given that they play football. Sorry, given that they love or play anything. Sorry for that. So what we are asked in this question to find probability that people who love cricket given that they love football. They love football. We are asked to find this. Okay, so what is this? What is its formula? It is equal to probability of, sorry for double equal to, probability of C intersection F upon probability of F. Now let's put the values here. What is the probability of C intersection F? We are given a Venn diagram here. Probability of C, sorry, E, not C, E. Oh, sorry. Probability of E intersection F. We are given a Venn diagram. According to this Venn diagram, probability of E intersection F, or you can say E and F, is 0.1. What is the probability that people love football? 0.7. So its answer is equal to 1 upon 7. Now, I have seen people that many of these people, what you can say, are confused in these notations that this is intersection and what all. So let's firstly understand the notations. And so and can be written as E intersection F that we have seen here. It can be also written as EF. And it can be also written as E and F. Now let's see some notations of OR. You can also write OR as E union F. You can also write OR as E or F. I'm not able to recall more notations, but yeah, these notations are, you can say, commonly used. And for conditional, probability of E given F, probability of E given, let's say, FG. You are given in a question probability of E given FG and some value. What do you mean by this? It means that event F and G has happened. Now, what is the probability of E will happen given that F event and G event has already happened? This is you. Since there are no notations between F and G, you can also represent this as AND. A and D, as we have represented here, right? Now, let's move to a concept called as chain rule. What we have discussed here? We have discussed in the above, that is conditional probability, right? Probability of E given F equal to probability of E and F, or you can say probability of EF. Notations, I have explained the notations above. You can write any one of the notations of AND here, right? EF upon probability of F. Now, in some questions, if you are asked to find the probability of E and F, you can do simple algebra here. It is equal to, yeah, it complies. Probability of E and F is equal to probability of E given F multiplied by probability of F. This is chain rule of probability. Chain rule of probability. Probability. Okay. So just like algebra. Okay. So we can write probability of E and F equal to probability of E given F multiplied by probability of F. Take a note of this thing, because in the later concept, in this lecture only, we are going to cover total probability theorem, and this concept we are going to use in that total probability theorem also, right? Now we are going to see a generalized version of chain rule. General, GEN. Disclaimer, I can write wrong spellings. That is my hobby. Sorry for that. Generalized chain rule. Just take a note of this, and if you just go through it 4 or 5 times, you will understand it by throat, or what is the word, I don't know. Because this is where it looks difficult, a lot difficult, mind it, but it is very easy. First I'm going to write it E1 and E2 and E3 dot 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 En is equal to, I am writing here equal to because there is no space left here, probability of E1 multiply by probability of E1 given E2 multiply by probability of E1 given E2 and E3. Since I am writing no notations here between E2 and E3, it means that E2 and E3 multiply by probability of E1 En. Sorry, I have just blundered here. This is not like this. Probability of E1 multiply by probability of E2 given E1. Sorry for that mishap. Probability of E3 given E1 and E2. Again, I'm going to explain it because this is very important concept. Since there are no notations between E1 event and E2 event, it means that E1 and E2 multiply by dot 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 probability of En given probability of E1, E2, En minus 1. This is a generalized version of chain rule. This is chain rule. This is generalized version of chain. Now let's take a question. Okay. First, let's read this question thoroughly. Okay, pause this. Again, I'm going to, sorry for that. Again, I'm going to say, pause this lecture, read this question, try to solve this question, and I'm here to explain the solution. So don't worry about that. So let's read this question together. In the morning, when baby wakes up, baby has 50% chance of having pooped. The chance of baby cries, given that she has pooped, is 50%. What is the probability that baby has pooped given cries? Just wait a second. I was just closing the fans because I have to speak a lot louder when the fans are on. Now I am comfortable. Let's read the question once again. In the morning, when baby wakes up, baby has 50% of chance, 50% chance of having pooped. Let's notate pooped, P-O-O-P-E-D, P-O-O-P-E-D is equal to B. Because if we write P, then probability of P, it doesn't look good, at least to me. So the probability of pooped, what we are given? 50% chance of having pooped, 0.5. There are 50% chance that baby has pooped. The chance baby cries, given that she has pooped, is 50%. The chance baby cries, given that she has pooped, yeah, given that baby has pooped, she, so the baby is girl, is 50%. What is the probability that baby has pooped? Baby has pooped question is wrong here. Baby has pooped, given cries. Nahi, sorry. Question is correct. What is the probability that baby has pooped and cries? Okay. Since again I'm I don't know how many times I have repeated this, but again I'm going to repeat it so that this concept goes in directly into your brain. Okay. Since I'm not writing any notations between event B and event C, it means that B and C or B intersection C. BC. I like BC. Okay. So what is the probability of baby has pooped and cried? Okay. So in the earlier concept of this lecture only, not the previous lecture, this lecture only, we have discussed conditional probability. What was it? Probability of E given F was probability of E intersection F upon probability of F. So let's write this. Probability of cries given pooped is equal to probability of C intersection B or CB. We can also write CB upon probability of B. Now we have to find probability of CB or BC or CB. Both are same. Okay. Both are same. Let's write BC only here. BC. So what will be the probability of BC? Simply let's multiply this denominator by here, which is equal to probability of C given B multiplied by probability of B. Simple. Do we know probability of C given B? Yes. It is 0.5. Do we know the probability of B? It is 0.5. Then what is the probability of BC? I think you are capable to answer this question. It is 0.25. Right. So this is our solution or answer. So the probability that baby has pooped and cried, both of them is 0.25. Now we are going to the concept called as total probability theorem. Okay. I think so. I have explained it down there. Yeah. I have explained. So I'm not writing this here. I am going to take the help of my explanation also, that explanation only that I have written. So what is law of total probability theorem? Probability of E is equal to probability of E given F multiplied by probability of F plus probability of E given F complement multiplied by probability of F complement. And I know you don't understand the shit from this formula. So let me try to explain you this law of total probability. Okay. We have to find probability of event E here. Okay. So what is the probability of event E here? Okay. In this Venn diagram, I am talking about this in this Venn diagram. What is the probability of E here? It is F and E, F and E. This part, this is a different event. Let me shade it in another color. Let's say blue. The event that is shaded in blue is F event. An event that is shaded in what color you want to take? Pink. Correct? Color has not changed. Pink. Done. The event that is shaded in, I don't know which color is this, is F complement or the event that is not F, right? Okay. So what is this event? It is F and E plus, what is this event? F, E and F complement, or you can say F complement multiplied by E. Now, I have told you in this lecture only that we are going to use a concept in the later part of this lecture of the conditional probability, which is chain rule, which is this, which we have derived. So what was the probability of E and F? Probability of E given F multiplied by probability of F. So same thing we are going to write here. What is probability of, I have not written P here, but I think so you can understand what I mean to say. So what is the probability of F and E? I have told you. Probability of F given E is F given E multiplied by probability of E. But we have to find the probability of E only. We don't know probability of E. So we know F and E is equal to E and F. E and F. So instead of writing FE, we can write EF easily. E multiply F complement. Simple. By this theorem. We all know that. So what is the probability of E? It is probability of E given F multiply probability of F plus probability of E given F complement multiply by probability of F complement. Now notice one thing. This thing which I have shaded in, you can say, big rectangle, and this thing is same, not similar, exactly same. Okay, take time on this concept also. Now let's solve this question. Again I am going to say sorry for that. Pause this lecture, read this question carefully, and try to solve this question on your own. This is a very good question. I think so because I haven't read it till now. Let's read it. In the morning when baby, sorry for the English. In the morning, baby has 50% chance of having pooped. Isn't it similar question? I don't think so. Answer. Probability of pooped is 0.5. The chance that the baby cries, given that the baby has pooped, is 50%. The chance that the baby cries, given that she has pooped, is 0.5. Baby cries, let's just read. The chance that baby cries, given that baby has pooped, is 50%. Okay. The Sorry for that. The probability that baby cries, given that baby has not pooped, the chance that baby cries, given that baby has not pooped, B complement, is 0.125. Find the probability of crying. I am giving you a hint. We are going to use the concept of total probability theorem that we have discussed just now, right? So what should be the approach to solve this question? We have to find the probability of C. As you can see, the same diagram that we have drawn here, the same diagram we will draw here. Instead of drawing this diagram, I'm going to copy paste this diagram so that it is easier for you to understand. Okay. Copy. It has been copied. It has been pasted here. Right. Right. You can, or wait a second, let's draw this diagram because there is a lot of annotation done on the diagram. So let's draw the diagram. This is our event space. Let's see this. Let's assume this is the probability of baby crying. Right? Let's say this part is baby has pooped and this part baby has not pooped. B complement. Okay. So we have to find this probability. So what is this part you can say? Think about it. What this part you can say? Probability of C equal to B and C. Probability of B and C. Take a careful look on this part. This is B and C. Probability of B and C. Probability of C is equal to probability of B and C plus, what is this part now? Let's take different color. What is this part now? Right. Probability of B complement and C, right? And obviously we can switch these positions also because we have switched these positions here also, right? Let me tell you why I'm switching these positions. Okay. What was the probability of B and C? Let's go to our previous example, previous where we have derived the probability of B and C, where we have derived in the chain rule, right? I'm not able to find it. Sorry for that. Yeah. What is the probability of E and F? E and F, probability of E given F multiplied by probability of F. So what is the probability of, sorry for showing you the next question. It is probability of B given C multiplied by probability of C. But do you know the probability of C? No, you are asked to find the probability of C. So you don't know the probability of C. That is why you are finding the probability of C. And to find the probability of C, you cannot use the probability of C. So we have to flip this end because flipping the end doesn't change the equation. Similarly, here also C and D complement. I have deliberately written this in an inverse, what you can say, in an opposite manner so that I can give you what you can say, a visualization on the total probability theorem, right? So what is C and B? Probability of C is equal to what is probability of C and B? We have derived it earlier also. C given B multiplied by probability of B. What is probability of C and B complement? Probability of C given B complement multiplied probability of B complement. Now what we have to do? Simple. Just put the values. I think so we have got all the values here. Here there is not a twist. Very easy concept which I have explained you in the previous lectures also and which is very basic. If we are given probability of B, can we find the probability of B complement? Of course. What is the probability of B complement? Is equal to 1 minus probability of B, which is equal to 1 minus 0.5. Oh shit, it is 0.5. Okay. So what is probability of C given B? It is 0.5. What is the probability of B? 0.5. What is the probability of C given B complement? 0.125. Now what is the probability of B complement? We have calculated it here. 0.5. So probability of C equal to probability of C equal to 0.25 plus what is 0.125 multiplied by 5? Let's multiply it here. 5, 5, 5, 2 carry, 10, 2, 1 carry, 625. And I think so there will be another point also, right? 0.0625. Probability of C will be equal to 0.23125. I think so my calculation is correct. And if not, I am definitely sure the concept is correct because it is correct. This is the probability that baby will cry, which we have asked in the questions also. Now, let's move to a different question. Again, I am going to say, pause this lecture and read this question carefully. Attempt this question on your own. And I hope you have really, really hope that you have paused this lecture and at least tried to attempt this question. Let's read the question. You have a bacteria in your gut that is causing a disease. Okay. 10% have a mutation. Sorry for the handwriting. Mutation. I think so. This handwriting is way worse than the previous one. Sorry for that. Let's read the question once more. You have a bacteria in your gut that is causing a disease. 10% have mutation. Let's write. The probability of mutation is 10%, which is 0.1. 0.1. Which makes them resistant to antibiotics. You have taken half course of antibiotics. What is the half course of antibiotics? This is a bit biology, not mathematics. Suppose the doctor has prescribed you 7 days of medicine, but you have taken only 3 days of medicine. Let's say doctor has prescribed you 8 days of medicine and you have taken 4 days of medicine. This is the half course, right? Let me remove this. Right. You have taken half course of antibiotics. Probability that the bacteria survives given it has a mutation is 20%. Probability that the bacteria survives given that it has a mutation is 20%. Right? Probability that the bacteria survives given that it has a mutation is 20%. Probability that the bacteria survives given that it doesn't have mutation complement is 0. Not 1, 0.01 because 1%. What is the probability that the randomly chosen bacteria survives? What is its probability? It is similar to the previous question that we have discussed, exactly similar to the previous question, only the language of this question has been changed. Okay, can I copy that? I can, but I won't. This is we are drawing a Venn diagram. Okay. So what is this probability? This is the probability that the bacteria survives. Survives. V-I-V-E-S. S. This part is mutation and this part is mutation complement. Now ask yourself, we have to calculate probability of S. What is this shaded part? Probability of S and M. Right? Probability of S and M. Plus, what is this differentiated part here? Analyze it. Probability of S and M complement. Right? Now, what we have discussed in the previous part of this lecture only, not the previous lecture, this lecture only in the conditional probability chain rule, it was what is the probability of S and M? Probability of S and M is probability of S given M multiplied by probability of M. Plus, what is the probability of S and M complement? Probability of S given M complement multiplied by probability of M complement. Oh, sorry to reveal the second topic that we are going to discuss, which is also revealed in the title of this lecture also. Probability of S. Are we given S given M? Oh yes, we are given S given M. What is the probability of mutation? Multiply by 0.1. Plus what is the probability of S given mutation complement? We are given 0.01. But we are not given probability of mutation complement. I think by now you are able to find the probability of mutation complement. Since we got the probability of mutation, the probability of mutation complement is equal to 1 minus probability of mutation, which is equal to 0.9. Multiply 0.9. So what is probability of survival of the this bacteria question? Yeah, bacteria. 0.02 plus 0.09. Now I think so you know the addition because I don't. Sorry for the lame joke. 0.11. So there is 11% chance that the bacteria survives. Now let's move to the next topic, which is Bayes theorem. But before doing the question on Bayes theorem, First, understand what is the Bayes theorem. Okay, let's move this question down, right? This is very easy concept. If you have understand conditional probability, this was the hard part that we have discussed in the previous part of the lecture. Bayes theorem is very easy. Let me tell you, Bayes theorem is very easy. What is Bayes theorem? We have given probability of E given F is probability of E and F. Let's write properly, proper notations, or also a bit neatly also. Probability of E given F is equal to probability of E and F upon probability of F. Okay, but we also know the probability of F given E is probability of F and E upon probability of E. And as you have known till now that this and this are equal. Sorry for this, what you can say, syntax. Okay, this and this are equal. So I can write here by chain rule that we have discussed in the previous part of the lecture, that probability of F and E is equal to probability of F given E multiplied by probability of E. Now we can fit it here. Probability of E given F is equal to probability of F given E multiplied by probability of E upon probability of F. This is our Bayes theorem. I think so it is pretty easy to understand because heavy lifting we have done in the starting part of the lecture. I like the magic problem. What was that? Let me just magic of probability, not magic problem, magic of probability. Now we have come to the Bayes theorem. Now let's solve its let's solve its question. But before solving, I am again going to say, pause this lecture, at least try to attempt this question, and after attempting, resume this lecture. I hope you have paused this lecture and at least read the first number of this question by your own. So now let's read the question by ourselves. 60% of all emails received previous year is spam. Okay. So 60% of all emails received previous year is spam. Spam is equal to 0.6. 20% of spam emails had the word dear. 20% of the spam emails have the word dear. Dear given spam. 20% of the spam emails, it means spam has been already occurred. Already we know that email is spam. Now that email has the word dear in it is 0.2. Not that word. The probability of the word dear in the spam is 0.2. Oof, my throat is paining. So that was 1% of the non-spam emails have the word dear. Dear, given the email is not spam, is not 0.1, 0.01 because, sorry for that, because 1%, not 10%. So 1% of non-spam emails has the word dear. You have get an email with the word dear in it. Okay. So we are sure that the word dear is there in the email. What is the probability that the email is spam? Okay. What is the probability that email is spam? Now we have derived the Bayes theorem here. I'm just going to write line by line so that it is easier for you to understand. Probability of S given D is equal to what I have written here, probability of opposite words D given S multiplied by probability of S upon probability of D. Probability of D. Now let's solve this question. Probability of S given D is equal to, what is the probability of D given S? It is 0.2. Multiply by, what is the probability of S? We have given this detail also in the question itself. Now what is the probability of D? We have not given the probability of D. There is a twist in this question. We are using here Bayes theorem plus total probability theorem also in this question. Again, we are going to make our Venn diagram. This is our probability, or you can say the word deer, not probability. This is the word deer. Okay. This event is what you can say spam. This is spam complement. Let me remove the lines because now I think so you are familiar. Spam, spam complement. What is this part? Probability of S and D. What is this part? Plus probability of S complement and D. Now we are going to write this reverse, and you know why. I think so till now. Probability of D and S. Probability of D and S complement. So probability of S given D is, what is this? 2 multiplied by 6, 0.12 upon. What is probability of D and S? We have discussed this previously also. D given S multiplied by probability of S plus, what is probability of D and S complement? Eraser was not on, was not able to activate itself. D and S complement multiply by probability of S complement. Now I think so we know all of these values. What is D and S? D given S, not D and S. D given S is 0.2. 0.12 upon 0.12 D given S 0.12. Now what we have to find? Probability of S. It is 0.16 multiplied by 0.16, not 16, it is 0.6. Sorry for that. 0.6. Wait. What is probability of D given S? 0.2. Sorry for that. Probability of D given S is 0.2 multiply by, what is probability of S? 0.6 plus, what is the probability of D and why I have written and here? D given S complement, it is 0.01. What is the probability of S complement here? Probability of S complement here is 0.4. Multiply by 0.4, which is equal to 0.12 upon 0.12 plus 0. What is this? 0.4. 0.12 upon 0.124, which is equal to 12 upon 12.4. Now I think so you all should have an calculator to convert it into percentage, and if you don't want, don't convert it into percentage, but this is our final answer. So what is the probability of, probability that the given email is spam? Probability that an email is spam is this 12 upon 12.4. So this is all for this lecture. I hope to see you in the next lecture soon. Thank you. Till then, take care.